Welcome to another deep dive. Today, we're stepping into a world where machines talk, data flows like a river, and factories get a serious intelligence upgrade. It's the Industrial Internet of Things, or IIoT for those in the know. We got a stack of fascinating material to unpack, academic papers, industry reports, even sneak peeks into cutting-edge projects.
And it's more than just slapping a Wi-Fi chip on a robot arm. We're talking about building an ecosystem that can handle the unique demands of a factory or refinery, places where reliability and speed are everything.
Okay, so paint a picture for me. What's the problem we're trying to solve here? I'm imagining a factory floor buzzing with robots, sensors gathering data on everything. But then what?
Imagine you're running a massive oil field. Sensors are monitoring pipelines spread across miles of rugged terrain. You can't have wires everywhere, and those sensors need to send data reliably for years without constant battery changes. That's where things get tricky. And interesting.
Right. So it's not just about collecting data. It's about getting that data where it needs to go reliably and efficiently. It sounds like traditional Wi-Fi just isn't going to cut it in these environments.
Exactly. We need something tougher. Something that can cover vast distances while sipping on battery power. That's where these LPWANs come into play. Low power, wide area networks. They're designed for exactly this kind of challenge.
LP wins. Sounds like something straight out of Star Wars. So
Yeah.
what are they, and how do they solve this connectivity problem?
Think of them as marathon runners of the data world. They can cover long distances using very little energy, perfect for those far-flung sensors. And there's a whole family of LPWAN technologies out there. LoRaWAN, NB-IoT, even cellular solutions like LTE-M and 5G getting in on the action.
Wait, 5G? I thought that was all about downloading movies at warp speed. What's it doing on a factory floor?
5G is more versatile than people think. While it's known for speed, it can also be configured for ultra-reliable, low-latency communication, which is crucial when you're controlling critical equipment.
So, it's like 5G has a secret industrial side hustle. This is starting to sound like a choose-your-fighter situation. How do we know which of these connectivity solutions is right for a specific application?
That's the million-dollar question. It depends on your needs. Do you need data flowing in real time, or can things be a bit more relaxed? How much data are we talking about? And of course, security is always a factor.
So many things to consider. It's like picking a phone plan. There are so many options, but one of these LPWAN seems to be getting a lot of buzz. LoRaWAN. What's the hype all about?
LoRaWAN is popular for a reason. It uses a unique approach called an Aloha-based medium access strategy. Imagine it like this. Devices shout their data into the network, and hopefully, it gets heard.
Hold on. Shouting data sounds a bit
Yeah.
chaotic. What happens if two devices try to shout at the same time?
That's where it gets clever. There are mechanisms to handle collisions. If a device senses a busy channel, it backs off and tries again later. And because it only transmits in short bursts, LoRaWAN is incredibly energy efficient. We're talking years of battery life for some devices.
Okay. Now that's impressive.
Yeah.
But I'm guessing it's not perfect for every situation. If it's all about short bursts of data, what are the limitations?
You're right, it's all about trade-offs. LoRaWAN's strength is low power consumption. But that comes at the cost of data rate. It's not ideal for applications that need to stream large amounts of data constantly.
Right, so you wouldn't use it to stream live video from your factory floor,
Mhm.
for example. But even with smaller chunks of data, it still feels like we're drinking from a fire hose here.
Yeah.
How do we manage this data deluge?
That's where edge computing steps in. Imagine instead of sending every bit of data to the cloud, we bring some of the processing power closer to the source, right there on the factory floor.
So we're talking about a mini brain right where the action is. Does that mean every machine gets its own dedicated computer?
Not quite a computer for each machine, but the idea is to distribute the processing power, and it goes beyond just one level. Think of it as a three-tiered system. Local nodes on individual machines, more powerful regional servers, and then the cloud for handling the really big stuff.
Okay, I'm seeing the appeal. You can handle simple tasks locally and only send the complex stuff up the chain. But if we're talking about making decisions in real time, isn't there a risk of these mini brains getting overwhelmed?
That's a great question. And that's precisely why we're not just throwing more hardware at the problem.
Yeah.
We're bringing in the big guns. Machine learning and AI, they're the key to making sense of all this data and automating tasks that used to require human intervention.
Machine learning in the factory. It sounds like we're stepping into the future. But what does that actually look like in practice? Are we talking about robots writing their own code?
Not quite robots writing code, but we are talking about machines learning from data and adapting their behavior. Imagine a sensor on a critical piece of equipment. Instead of just sending a temperature reading, it uses machine learning to predict potential failures based on subtle patterns in the data.
So, it's like a mechanic who can hear a problem before the engine even makes a noise. That's incredible. But we're still dealing with all those devices trying to talk at the same time. How do we make sure the data gets through reliably without everything turning into a digital shouting match?
You're right. Managing communication between all those devices is crucial. And it's not just about avoiding collisions, it's about making sure the most important data gets through first. That's where these random access protocols we mentioned earlier come into play.
Okay, remind me. Random access, it's like a digital free-for-all, right? How does that actually work in a system where reliability is so important?
Think of it like this. Each device has a chance to speak up, but there are rules in place to prevent chaos. If a device senses the network is busy, it waits a random amount of time before trying again. It's a bit like a polite conversation where everyone takes turns, but instead of raising their hands, they're listening for a gap in the chatter.
So it's controlled chaos with a dash of digital etiquette. But with so many devices, wouldn't this random system still be pretty slow?
That's where things get really interesting. We're not just throwing devices into a random lottery. We can use application-specific knowledge to make things smarter.
Application-specific knowledge. So we're telling the system which data is more important. Isn't that getting a bit too hands-on for something that's supposed to be automated?
It's about striking the right balance.
Sure.
We're giving the system guidelines, not micromanaging every message. Imagine you have a sensor monitoring safety systems and another one tracking temperature. The safety sensor's data needs to get through immediately, while the temperature reading can wait a bit.
So it's like a digital triage system. The most critical data gets rushed to the front of the line.
Yeah.
This is where that edge computing comes in handy again, right?
Exactly. Intelligent algorithms at the edge can analyze incoming data and decide what needs immediate attention and what can be queued up for later. It's all about balancing speed, reliability, and the unique demands of each application.
Okay. I'm seeing the power of this distributed intelligence. Processing data closer to the source and prioritizing the most important information. But it feels like we're still only talking about one side of the equation. What about reliability? No factory manager wants their production line grinding to a halt because of a network hiccup.
You're absolutely right. Reliability is paramount. A single point of failure can bring down the whole system. And that's not acceptable in an industrial environment. That's why we're not just relying on one connection. We're embracing multi-connectivity.
Multi-connectivity. You mean giving these devices multiple ways to connect to the network? Isn't that a bit overkill?
Think of it like having backup generators for your data. If one connection goes down, the others can pick up the slack seamlessly. And with clever techniques like physical layer abstraction, we can actually simulate and test these multi-connectivity scenarios to make sure they're rock solid.
Wait, we can simulate an entire network? How does that even work?
It's like building a digital twin of your network, testing different scenarios and predicting how the system will behave under pressure. We can simulate signal strength, interference, even component failures to identify potential weaknesses before they cause problems in the real world.
Okay, that's next level stuff. But all these backup systems and simulations, it sounds expensive and energy intensive. Are we sacrificing efficiency in the name of reliability?
That's the challenge, finding that sweet spot between reliability and efficiency. It's like trying to build a race car that's both lightning fast and sips fuel like a scooter. And it gets even more complex when you factor in battery-powered devices.
Right, those sensors scattered across the oil field or monitoring pipelines, they can't be plugged into a wall socket. How do we keep them running for years without sacrificing performance?
That's where clever power management techniques come in. We can limit how often devices transmit data, essentially putting them to sleep when they're not needed. There's also something called power saving mode, where devices only wake up at specific intervals to check for messages.
Yeah. It's like giving those sensors a strict sleep schedule, making sure they're only active when absolutely necessary. But doesn't that create a risk of missing important data? What if something happens while they're snoozing?
It's a delicate balancing act. We need to weigh the need for real-time data against the limitations of battery life. And the right approach will depend on the specific application. A sensor monitoring a critical safety system can't afford to miss anything, while a temperature sensor might only need to report data every few hours.
Okay, I'm starting to see how complex this gets.
Hmm.
But there's one big piece of the puzzle we haven't talked about yet: security. With all these connected devices, it feels like we're creating a hacker's paradise, What are we doing to keep these systems safe from cyber attacks?
You've hit the nail on the head. Security is absolutely crucial. And it's often overlooked. We're not just talking about protecting data, we're talking about protecting critical infrastructure. A cyber attack on an industrial control system could have devastating real-world consequences.
Okay, that's a sobering thought. But what are the specific threats we're facing here? Are we talking about shadowy figures in hoodies trying to take control of robots?
It's not always as dramatic as Hollywood makes it seem, but the threats are very real. We're talking about everything from invasive attacks where someone physically tampers with a device to more sophisticated software attacks that exploit vulnerabilities in the code.
So it's not just about locking the doors, it's about securing the entire system from top to bottom. How do we even begin to tackle a problem this complex?
One approach is to use isolation techniques. Imagine building a digital wall between critical systems and less secure components, limiting the damage an attacker can do even if they manage to breach the outer defenses.
It's like a digital fortress with multiple layers of protection. But are these isolation techniques enough? What's to stop a determined hacker from eventually finding a way through?
You're right. No security system is foolproof. And one of the challenges in IoT is that we're often relying on security solutions designed for traditional IT environments, which might not be a perfect fit for the unique demands of an industrial setting.
So there's room for improvement. And I imagine security is an area that's constantly evolving as new threats emerge. But before we get lost in the digital weeds, let's step back and see how all this comes together in the real world. I'm ready to see some of these IoT success stories in action. All right, let's shift gears from the technical deep dive and see how these IoT solutions are actually playing out in the real world. I'm ready for some mind-blowing examples.
Well, one area where we're seeing a huge impact is smart manufacturing. Picture a factory where machines are constantly talking to each other, optimizing production in real time. Sensors are tracking everything from the temperature of a furnace to the vibration of a robot arm, feeding all that data into edge computing systems for analysis and decision making.
So we're not just automating tasks, we're automating the entire production process. What does that actually look like on the factory floor?
Imagine a production line that can adapt to changes in demand on the fly. Say you're making custom sneakers, and suddenly everyone wants a specific color combination. With IIoT, the system can automatically adjust the production schedule, reroute materials, even tweak the settings on individual machines to meet those changing needs.
That's incredible. It's like the factory is thinking for itself,
Mm.
constantly optimizing and adapting. What about predictive maintenance? I keep hearing that buzzword thrown around. How does that actually work in practice?
Predictive maintenance is all about using data to anticipate problems before they cause a shutdown. Imagine you're running a factory with hundreds of motors. Traditional maintenance means checking them on a fixed schedule, whether they need it or not. With IoT and machine learning, those motors are constantly sending data about their performance. Temperature, vibration, power consumption.
So instead of waiting for something to break, we're looking for subtle clues that something might be going wrong. It's like having a doctor for your machines, constantly monitoring their vital signs.
Exactly. And the beauty of it is that you can catch those small problems before they turn into big ones. That means less downtime, lower maintenance costs, and a smoother, more efficient operation overall.
Okay, I'm sold on smart manufacturing, but what about the world outside the factory walls? IoT feels like it has the potential to revolutionize so many industries. What other applications are we seeing out there?
One area that's generating a lot of excitement is autonomous driving. We're talking about vehicles equipped with an array of sensors, cameras, radar, LiDAR, all working together to create a real-time map of the surrounding environment and to process all that data and make split-second driving decisions. We need the power of edge computing.
Right, because if your car is trying to decide whether to brake or swerve, it can't be waiting for data to be sent to the cloud and back. It's got to make those decisions in a fraction of a second. But I imagine security is a major concern here. What's to stop a hacker from taking control of a self-driving car?
You're getting on a critical point. Security is paramount in any IIoT application, but especially when we're talking about something like autonomous driving, that's why these systems are designed with multiple layers of redundancy and security protocols. We're talking about multi-connectivity, secure communication channels, and sophisticated intrusion detection systems.
So it's like building a digital vault around the car's control systems. But even with all those safeguards, I think a lot of people are still hesitant about handing over the wheel to a computer. What are your thoughts on that?
It's understandable that people are cautious about new technology, especially when it comes to something as personal as driving. But the potential benefits are huge. Increased safety, reduce traffic congestion,
Yeah.
and greater accessibility for people who can't drive themselves. And as the technology matures and we see more real-world deployments, I think that hesitancy will start to fade.
Right. It's all about building trust and demonstrating that these systems are reliable and safe. But autonomous driving isn't the only thing happening on the roads. What about smart logistics? I feel like there's a huge opportunity to optimize delivery routes, reduce fuel consumption, and maybe even eliminate those annoying traffic jams.
Absolutely. Smart logistics is another area where IIoT is making a big impact. Imagine a fleet of delivery trucks, all connected to a central hub, constantly sharing data about traffic conditions, weather, and even customer demand. The system can optimize routes in real time, minimizing delays and maximizing efficiency.
So no more packages stuck in traffic. That's a dream come true. But beyond just optimizing routes, what other benefits can we expect to see from smart logistics?
Well, with real-time tracking and monitoring, we can improve the security of shipments and reduce the risk of theft or damage. And with sensors tracking everything from temperature to humidity, we can ensure that sensitive goods, like food or medicine, are transported under the right conditions.
It feels like we're just scratching a surface here. With every example we discuss, I see even more potential applications for IIoT. It's really about connecting everything and using data to make smarter decisions in every aspect of our lives.
That's exactly it. And the key takeaway is that IoT is more than just connecting devices. It's about creating a seamless, intelligent ecosystem where data flows freely and systems can adapt and optimize themselves in real time.
So it's not just about the technology itself, it's about how we use it to solve problems and create a more efficient, sustainable, and connected world.
And that brings us to a thought-provoking question. With all this potential, what will the factory of the future look like? How will these technologies continue to evolve and shape the way we work and live?
That's a question for all of us to ponder. The journey to a smarter, more connected future has just begun. And it's going to be an exciting ride. Thanks for joining us on this deep dive into the world of industrial IoT. Until next time.